Hi everyone, this is Mr. Benjamin, and today we'll be looking at how we write explanations in Redox using oxidation states. Okay, so let's get to it. So the question can be phrased as such. Explain in each of the following reactions, identify which one is oxidized, which one is reduced, and we use our answer in terms of changes in oxidation state. So we must remember SHOE plus minus plus minus. S stands for oxidation state, H stands for hydrogen, O stands for oxygen, and E stands for electron. And this is plus minus. Again, these are all for oxidation. So oxidation is the increase in oxidation state, while reduction is a decrease in oxidation state. All right, so let's look at, for example, so we got this reaction that we can see over here. So the first thing that we should do is that we should fill in the oxidation states. So we can see for the first one, we got I minus. There's already a charge there. So I minus will be a -1. Okay, next one is Br2. So Br2 is an element, and element is 0. Next one, I2, iodine is an element, and element is 0. And then Br minus, because it's a negative, so we got a -1 over here. So we can see the iodine changed from -1 to 0, while bromine changed from a 0 to a -1. So when I go from -1 to 0, this is an increase. So therefore, the iodine in the iodide has oxidized. It has oxidized the iodine in the iodide ion. Okay, so it's the iodine species in the iodide ion. So what is the reason? How do we write this? So it's very important for you to follow this explanation. So the iodine in the iodide ion is oxidized as its oxidation state increased from -1, which is the start, to 0, which is the end, in iodine. So what we need to have is the species in the reactant. So this one is the reactant. And then whether oxidized or reduced. Okay, whether oxidized or reduced. And then whether increase or decrease, starting and ending. Right, starting and ending. And then what is the product? Okay, so let's try for the next one. So we can see that bromine went from 0 to -1. So that's a decrease. Decrease in oxidation state is a reduction. So we say the species bromine in bromine liquid, or bromine aqueous. Right, so how we say is the species, which is bromine in bromine, which is Br2, is reduced. Right, oxidation state decrease, and then it decreased from what? 0 to 1, -1, and then the product that it decreased to is bromide ion. Now, some of us might think that it's very strange to write bromine in bromine, right? However, in different examples, it might get a bit more complicated, and this is actually a very good habit for you. Okay, so that's how you write. So let's try a few examples together. Okay, so the first example, we have this reaction, Zn, zinc plus a copper 2 ion, give me a zinc ion and then a copper metal. So what's going to happen here is that zinc is an element, so element is 0. Copper 2 plus, so it's +2. Zinc 2 plus, so it's +2. And then copper, because it's an element, it is 0. So we can see that the zinc went from 0 to +2, while copper went from +2 to 0. So we can see that zinc has increased oxidation state, while copper has decreased. So the substance that has been oxidized is the zinc in zinc metal, while the copper in the copper ion has been reduced. Right, so the zinc and the zinc metal has oxidized, while the copper and the copper ion has been reduced. So what's the reason? So let's use the format that we have learned. So we will say that the zinc in zinc metal is oxidized as its oxidation state, right? Its oxidation state increased because the oxidation is increased oxidation state, right? Okay, from what to what, right? From originally here is 0 and then to +2. So from 0 to +2. And then we must tell me what's the product to form zinc 2 plus ion, so zinc ion. Right? So this is how we write. Remember the species, the starting reactant, whether oxidized or reduced, whether increase or decrease, starting to end, and then product. Alright, so let's try one more time. Next one. So over here, we have copper. So we say that the copper in copper 2 ion is reduced as its oxidation state decrease, because reduction is decrease from starting is +2 to 0 to form copper metal. Alright, so again, the species, the reactant, whether reduce or oxidize, whether increase or decrease, starting to ending, and then the product. Okay, so let's try one more example, then you can see why it is very important to phrase it like this. So let's say part C. Okay, so we got FeCl2 to Cl plus Cl2 give me FeCl3. So we can tell that this Fe is a +2 because there's 2 Cl minus, this one is a -1. Right, Cl here is -1, there's 2 of them, so it's a -2, and then therefore the Fe is +2. Next one, chlorine is an element. Chlorine is an element, so element is 0. Right, so the Cl is also always -1 here, right? And then because there's 3 of them, so the Fe here is +3. So we can tell that the Fe here increased from +2 to +3. But the Cl, right, it is not the Cl from here. It is the Cl from here, the chlorine gas, not from the FeCl2. It's the Cl from the chlorine gas that went from 0 to -1. So that's why we need to write it properly. Okay, so the substance that's oxidized is actually the Fe in FeCl2. Right? Yeah, oxidized. And the one that's being reduced is actually the chlorine, Cl, in the chlorine gas, Cl2. Not the chlorine in the FeCl2. So how do we write this? So we write Fe in FeCl2 is oxidized as its oxidation state. Try this by yourself. State increase from +2 to +3 to form FeCl3. Okay, so the species, the reactant, oxidize or reduce, increase or decrease, starting to ending, and then the product. Right, the next one, maybe you can try. You pause the video and you try, and then you check whether it's correct. Okay, so check whether it's correct. So you see the chlorine in chlorine gas, Cl2 gas, right, is reduced as its oxidation state decreased from 0, which is an element, to -1 to form FeCl3. So the species, the reactant, reduce or oxidize, decrease or increase, starting to ending oxidation state, and final product. Okay, so I hope this has been helpful for you. All the best.